practice test. So we have two box plots that summarize the number of miles driven in 2 months. Which statements must be true about the distributions? So there could be more than one, or there could be one, but you have to check all of them if it says which statements. So in that case, I'm just going from top to bottom. The total number of miles driven in August is the same as the total number of miles driven in December. True or false? The total number of miles driven in August, which is this one, is the same as the total number of miles driven in December. Oh. False. Where do you look at to determine that? Okay, where on the box? Okay, well, that could tell you it is more spread out, so it's probably not the same. For total number, I would look at from like the minimum to the maximum on each. Okay, so like my total number here would be about 61 minus about 5. And this one's like about 61 minus about 10. So they do not have the same total miles driven. Okay, so definitely not the first one. The second one says half of the time drivers went further than 40 miles per day. True or false? True. All right, so let's see. Here's half, right? Because the median cuts your data in half. So I'm going to look at the median on both because it's talking about both. So half of the time drivers went further than 40 miles per day. That is true for both of the months. So I'm going to pick this one as one of the answer options and then still check the rest. The median miles driven in August is equal to the median miles driven in December. True or false? True. So the part that tells you the median is that middle line of the box. They're both on 40, so that is true. In December, drivers typically drove more miles per day than in August. True or false? I would say false as well. So in August, as you can see, it's bigger, like it's bigger in the range and in the interquartile range. So in December, it's smaller. So the question was, in December, drivers typically drive more. Well, no, it's less in December. So we're not going to pick that one. And then the IQR, the interquartile ranges for both months are equal. True or false? Definitely false. Because you don't even have to do the math for it. You could. What's the formula for IQR? Okay, good. So you don't have to do the math for this one though, because the boxes itself are a different size. So no, they are not equal. If you did the math, this IQR is about 40 and this IQR is about 20. So definitely different. That's like the one calculation Desmos won't tell you is IQR. You have to know it's Q3 minus Q1. Let me just make sure this matches the key that I have. Okay. So plots show the number of hours of video games played by two students, Jerome and Sarah. We're going to select all that must be true. So first is that the mean and median values for Jerome's data are about the same. Yes or no? So how do you know when they are about the same? Did you actually like do the math for it? Okay. You don't have to do the math for it. You could if you really want to know for sure. But how do you know just looking at it if the mean and median are about the same? So when it is skewed, because it is skewed on this one, the mean and median are probably not. Okay, when the data is symmetric, which would you say that Sarah's data is symmetric, or at least roughly symmetric? Yeah, it's roughly symmetric. There's like maybe 2 points that make it not perfect, but data rarely is perfect. When the data is symmetric or roughly symmetric, then we could expect the mean and median to be the same. So I would not pick the first one. I would pick the second one, where it says Sarah's are about the same, because hers are roughly symmetric. The mean would be about, and median would be about here in the middle. Okay, so that's how you know if it's symmetric, mean and median are about the same. Then moving on, Sarah's standard deviation is higher than Jerome's, yes or no? Okay, so for these ones, the standard deviation ones, sometimes it's really easy to tell which one is more spread out or not. This one is hard for me to tell personally. So since I do have the values, I would probably put both of these in Desmos and then compare them and then know for sure. I will show you that, you know, just to make sure we all know how to do that, because the only way to do standard deviation right now is with the calculator. But when I did it earlier, I think Jerome's was about 1.7-ish. Or I think about 1.8. See, like they were pretty close to each other. I think Jerome's was about 1.8 and Sarah's was about 1.7. Like they were pretty close. So that I would have to put in the calculator to know for sure. If I remember the answer key correctly, it ends up being, but I'll show you with the actual calculator in a little bit. All right, but I agree, put that in the calculator. It is hard to tell on this one. So then the next one, the median values for both students is about the same. Yes or no? So I can tell you Sarah's median is about 3, or it is 3 exactly, if I remember when I did it earlier. Where is Jerome's median about? About the 1 or the 2. I could do the math and know for sure. But like if his is about the 1 or the 2, and Sarah's is about 3, are they the same? So then don't pick that one. The mean values for both students is about the same. Yes or no? Okay, did you do the calculation? Okay, so just looking at it, since Sarah's is symmetric, I know her mean is probably somewhere around the 3. Since Jerome's is not, well, his median's about here, but these bigger numbers pull the mean to be higher. Like these are kind of outliers, but they're not really outliers. So I would say that they're not about the same. I mean, I could check when I go and do the standard deviation. It would be really easy to also just check the means. But visually, I would say that they're probably not about the same. Because Jerome has a lot of numbers from 0 to 2. And Sarah does not. Like they're more higher. Does that make sense? So there's ways to tell just looking at it, and then there's ways to confirm with the calculator. I would not need a calculator to say that. All right, so then the next one. If Jerome stayed home sick from school on Tuesday and played 10 hours, this would affect the mean value for him more than the median value. So Jerome's values go from like 0 to 6, mostly toward the left side of the number line. What this is saying is that we're now going to add a data point of 10, which if I extended this would be like way over here. Would that affect the mean more than the median? Yes or no? Yes, it would. Okay, because the mean is very much affected by any outliers. by rule of thumb, the mean is affected by any number that you add or subtract to the data. The median, which I could do the math and see. So I have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So half of 16 is 8, so that would be making my median 1. It would actually be this dot. Does adding an additional dot way over here affect my median? All right, it doesn't. So in that case, you would pick this one as an answer. Because it does affect the mean more than the median for him. And then for Sarah, if she stayed home from sick on Tuesday and played 10 hours, this would affect the median value for her. Medians usually aren't affected by outliers, but we'll see, like you can know for sure. Because you can see all the dots. She had her median, if I remember correctly, was like somewhere over here. One of these dots on the trees. If I added a data point of 10 way over here, would that change her median? All right, it doesn't, it stays the same. So it would just be these 3 answers. But I'm gonna show you Desmos real quick, and you need to know that for your test. So let's review that. Because again, the standard deviations are hard to tell when it's these 2 data sets. So I will check. Okay, but I would put both in Desmos. I would put J for Jerome. So like you always put a letter equals bracket and then you type in your data. So I have 5 zeros, 4 ones, 3 twos, 1 3 4 5 6. All right, because Jerome had 16 data points. I think the easiest way to find the standard deviation is through this little keypad menu. Go to functions, scroll to statistics. There's a few standard deviations. Just pick one, like I'll pick this one. And then I'll type in J for this data. So his is about 1.87-ish. Sarah's, I'll put in now, is, let's see, there's 5 3s. 4 4s, 2 5s, a 6, and a 7. So she had 19 data points. And then if I do my standard deviation of hers, it's about 1.75. So these ones had really similar standard deviations. That's why I even had to go in and check. But then since you have to go in and check that, you could also check like the means where it was comparing the means and stuff. It's just for some of them, you don't have to. You could just tell visually. So all of that Desmos could do and could save you some time on the test. Questions on that? Okay, any other questions from any study guide, the paper or otherwise? Yes? All right. So a sample box or a sample of 10 boxes of raisins has these weights in grams, and which of these box plots best represents the data. So I don't know if it lets you do copy and paste in Illuminate because you'll be taking your test in Illuminate tomorrow. If it doesn't, then you can just put it on a piece of paper and then copy it into Desmos because you will have Desmos tomorrow on the test. If it were me and I had to make a box plot, I would just use Desmos, even though I know how to do it by hand as well. And then if I remember this function, because it's not in the menu, but it's stats.
and then parentheses, whatever you call your data, it'll give me my 5-number summary. And that is what I need for a box plot. So remember that, because I can't help you with the calculator tomorrow on the test, but you could do that and then match it up to the ones that have the same 5-number summary. So they all start at 25, so that doesn't help me. They all end at 38 except for B. The median, it has to be 32, so that leaves me between answer options D and A. And then, so now we need to match up these quartiles. So 35 and 29, it looks like my answer is A. Let me just compare to D just to be sure. All right, that is not 29, so it has to be A, process of elimination. Questions on that? Okay, so there's that. And then the rest of the questions say, about half of the boxes sampled have weights above what weight? Well, if I look back to box plot A, where is my like halfway point of a box plot? On this one, it's 32. So the halfway point of a box plot is the middle line of your box, right? So then the answer for that one would be half of them are above 32. And then half of them are below 32. So that's the answer for that one. And then what percent of the boxes have a weight above 29 grams? Well, I'm going to go back up and look. The 29 is here on the box plot. So what percent is above the 29? Yeah. 75%. Because remember what splits the data into percents on a box plot? The quartiles. So like here's my Q1, my Q2, my Q3, and that's on the box. So that makes it 25% here, 25% there, 25% there, and 25% here. And then the question was, what percent is above the 29 grams? So then you count 25 to 25 to 25 is 75%. Makes sense? Any questions? From either study guide, you might have time for one more. Yes, number 9 on this one, or I thought we did that. So let me check. Yeah, this one was the first one we did today. Let's see. All right, now my thing is glitching out. So yeah, can you still be helping this one? Yeah, we did this one. Okay, well, sorry, let's do a different one. I can help you one-on-one, but we did do this one today earlier. So what other ones do we need help with? You might have time for one more. Number 10. Okay, so the mean vitamin C level for 20 dogs was 7.6 milligrams per liter, with a standard deviation of 2.1 milligrams per liter. So one dog's vitamin C level was not in the normal range. It was 0.9 milligrams per liter, which is a very low level of vitamin C. So if the 0.9 is eliminated from the data set, what would happen to the mean? So if you need help visualizing this, it said that my mean is about 7.6. So let me just put like numbers on here. If it's about 7.6, then that means most of my data is like around here. What it looks like exactly, I don't know because it doesn't tell me. But if that's my mean, then most of my data is around there. And then it says that we have a data point on a 0.9. So in that case, 0.9 would be like here, way over here. If we eliminate it, what does that do to the mean? Does it increase it or decrease it? It increases. Why? Which one makes the most sense?
because the 0.9 was an outlier. All right, when we eliminate an extreme value, extreme values pull the mean in that direction. So if I get rid of it, now the mean goes back the other way, right, where the middle is. So it would increase the mean if I eliminate it. And then if that value is eliminated, what would happen to the standard deviation, how spread out the data is? It would decrease, because now it's not spread out as much. Okay, does that make sense? Okay, Ryan, I'll come back to you. Any other last minute questions? So when I had checked earlier, no one met the goal, so try again tomorrow. I was having the bingo be for tomorrow for math lab for the other assessment grade, but this is an assessment grade too, getting 80% or higher on both. I think we'll do one more time.